This is the continuation of our Fruitvale class on section 8.3. We just got through with A, now then we're going to 8.3, B part, second part of it. This time we're going to work problems. You're responsible for problems 43 through 75 odd. So let's pick one of those out. We'll just start off with the first one there. We've got this vector drawn. and 5, and they want our answer in this form for this vector. And so we talked about it in the first part of the lesson. We know that our x value is equal to r cosine theta, and our y value is equal to r sine theta. And of course, this is where the x value goes, this is where the y value goes, that component, the y component. So, if I'm doing my first one, x would be equal to r, which is 5. Make sure that the 5 is what they have, and they do. All right, cosine of theta, and theta in this case is 30 degrees. Of course, we know that's the square root of 3 over 2. We have this memorized. 1, 2, square root of 3, 30, 60. And we know that cosine is adjacent over hypotenuse, so like I said, that would be the square root of 3 over 2. So 5 times the square root of 3 over 2, which would give me 5 square root of 3 over 2. So the x component is 5 square root of 3 over 2. Now then we're going to find our y component, and y is equal to r sine theta. R is 5. Sine of 30 degrees, that would be 5 times 1/2. We know that sine of 30 is opposite over hypotenuse, so that would be 1/2. And that would give us 5/2 for the y component, or as they call it, the vertical component. And this would be the answer to problem number 43. And of course, 43 through 48 are all done the same way. I want us to look down at number 49. It says we have a force of 250, which we'll represent with a vector, and a force of 450 with an angle in between of 85. So this angle is 85 degrees. I can write 85. And it has a magnitude of 450 newtons. Now, Newton is a measure of force, so we're not all that concerned with the units that it's being measured in. We're worried about the 250 and the 450. And it asks us to find the magnitude of the resultant vector. Now remember, when we had vectors, we go tail to head. Two ways we can do it. I'm going to do it where I just bring this over here, and I'm going to draw it like so. And my resultant vector going from tail to head is this right here. And we want to know what this value is. I'm going to put a C on it since it would kind of look like we're going to use law of cosine to make it look that way. If this whole angle in here is 85, we know that these two angles add up to 180. 180 minus 85 would be 95. When we move the vector over, it keeps the same direction, the same magnitude. Therefore, this is 450 right here. So we have a triangle in which we're given angle, side, angle, side. Now, if we were in our comp math class, we would use our program. We use it over and over, and we'd use our program. Not in our comp math class, so we're going to use law of cosines. So we call this side C. C would be equal to the square root of a squared plus b squared minus 2ab cosine of c. As we plug into that, let me get a drink of water just a minute. When we plug in, we have the square root of a squared, which would be 250, plus b squared, which would be 450, minus 2 times A, which is 250, times B, which is 450, times cosine of C, which would be cosine of 95 degrees. Now we're just going to plug that into our calculator. And I suspect you guys already got it plugged in. Second square root, I've got 250 squared plus 450 squared minus 2 times 250 times 450, that's 450, times cosine of 95. And when I hit enter, I'm coming up with 533 for the magnitude of the resultant vector. And that's what they were asking for. Now, problems number 45 through 52 are exactly the same kind of problem, exactly alike. The only difference is that on 49 through 52, they don't have it drawn for you. You're going to have to draw it and then work it out. Let's go on down to problem number 53. And 53 is actually the same thing again. I'm not sure why they 43 through 56 are the same kind of problem. They say use the parallelogram rule, and of course we can do it both ways, to find the magnitude of the resultant force for the two forces shown in each figure. Round answers to the nearest 10. Same thing. 43 through 56 are doing the same kind of problem. Now, once you go down to 59, and we talked about problems like 59, they tell me that vector u has component vectors of -2 and 5, and v has component vectors of 4 and 3. And like if I'm doing 59, it wants to know what u minus v is. U minus v. I'm going to take the difference in the x values of vector u, so that would be -2 minus 4, which would be -6. And in the y values from u to v, that would be 5 minus 3, which would be 2. We'd like for all of them to be that easy. As a matter of fact, all the problems on 59 through 66 are that easy. Some of them have a scalar involved, and we've already talked about scalars. For example, if I were to do number 63, I'd multiply 3 by the u, and I would multiply 6 to the v. I'll just go ahead and work it. We got plenty of time. We've got 3u minus 6v. And we want to know what that's equal to. So 3u, that'd be 3 times this. So that'd give me -6, 15. And then we've got minus, and we've got 6 times v. 6 times 4 is 24. 6 times 3 is 18. I've got -6 minus 24, that would be a -30. I've got 15 minus 18, that would be a -3. And there is my vector that is the difference in 3u and 6v. Okay, looking down at 67. And again, these problems we talked about a little bit earlier in the section, but we'll go ahead and work one of them anyway. It has the vector -5, 8, and they ask us to write this in AI plus BJ form. And that means in this particular case that A is -5, so we have -5i, and plus, and B is 8, so we have 8j. And so this and this are the same thing, it's just a different form that it's written in. Why they give two different forms, I don't know. I just know that they do, and they ask us to understand both forms. Look over at problem number 71. And they ask us to find the dot product. To find the dot product of two vectors, all we do is multiply the x components together, and 6 times 2 is 12, and the y components together, -1 times 5 is -5, and there is the dot product for these two vectors. And that gets us through 76. Guys, again, spend the time necessary. A lot of these dot product, we've had that in comp math. I feel like that we've had the IJ form of vectors in comp math. Biggest part of this section we've had in comp math. The only difference is that in comp math, a lot of times we used our program triangles, or we went to everything and used triangles under everything, and we were able to make the problem a little bit faster in order to handle it in competition, but the concepts haven't changed. They're exactly the same. Most of this stuff you already know how to do, but work enough of these problems that you're going to be ready when we give the final at the end of the semester. Both of you guys love this stuff. I know you'll be ready. Again, and I think I'm probably going to close all our lessons like this. You guys do what they tell you to do when it comes to being healthy. You stay out of large groups, keep your hands washed, use hand sanitizer, don't do dumb things, take care of yourself, and we'll pick up again at the next lesson.